Hi everyone, welcome back. In this video we are gonna learn about Mahalanobis function. This function is very important and a popular function we can say because this is used in computer vision, image processing, machine learning, deep learning, and also in statistics. This function is used widely, so that's why this is important function. In this video we are gonna learn about the purpose of and the usage of this function. Of course we are not gonna talk about the formula. I am also not familiar with the formula, so of course I'm always skipping the formula parts because this is details. I'm just focusing the usage and the purpose of the function. Also in here there are not many explanations. Then I get into the deep investigation. I checked the Gary Brasky example in his GitHub. In here there is an example for explanation of Mahalanobis distance function. So when I check, I understood the usage, then I'm gonna explain you accordingly. You can also check in here. Gary Brasky is one of the creator of OpenCV. So yeah, we can switch to the code part, I think. And here I already established some codes because I want to earn time. There are not important things in here, we can say. Let's run the code maybe before explaining the code. What I'm doing, I just created two group, which is the group 1 yellow circles, and the group 2 is blue circles. I just assigned some numbers, and I just created two clusters, I can say. Why I created these clusters? Because to explain this Mahalanobis function. In machine learning, in statistics, most of the time you are gonna have clusters. Of course, not two. Most of the times you will have more than 2, 5, 50, continue like that. So for this example, I have just two clusters. After you get your clusters, new data is gonna come to your clusters. So you need to classify this new data, new point maybe. Yeah. For example, let's say in my mouse cursor in this part, let's say a new point pops up. So we need to decide this new point is gonna be included in the yellow cluster or in the blue cluster. This is an important for most of the cases. You can easily say by looking to the cursor of mouse, okay, this is needed to be of course the yellow cluster, but how machine is gonna know that? So in this time, Mahalanobis distance is gonna help us. So simply it's just deciding, it's just classifying the new point, new data coming into the clusters. It's gonna decide which is gonna have this new point, new data. So basically, Mahalanobis function is helping us to classify the data. Okay. Also in my YouTube channel, you can check how to linear regression or single perceptron, single layer perceptron. About that, I have a neural networks video. You can check that. For example, there is a line how to differentiate two clusters. That's an interesting part, also related to this one. Maybe you can check that. It's not about OpenCV kind of, but kind of neural network example. You can also check that one. So basically, yeah, Mahalanobis distance is just helping us to classify data. Okay. So how we are gonna continue? According to the example I check Gary Brasky in GitHub, basically we need to first of all get our covariance and the mean matrix. That's why in here I already create some maths. So we continue in that way. Okay. After that, we can, for the group 1, we can calculate first of all, we need to push these points into the group 1 first of all, because these are still points. How we are gonna do that? First of all, we need to create a math. Let's say sample, and after that we are gonna equal to cv math, and let's say 1 row and 2 columns. Of course, type is gonna be 32 float. Okay. And after this, also this can be like this, channel 1. Then we need to assign the points into this sample math. And how we are gonna do that? Like this. And this is gonna be of course 0 to 1. And okay, since this is done, is equal to this is the point group 1. The element we need to get, I dot x. Okay, so also similarly this is the zeroth row, first column. Similarly also we need to do for the second column of this sample. Why we are doing this? Because we are gonna push this into the group 1. So we are gonna use this group 1 to be able to calculate covariance and the mean. Because we are gonna use also, of course, calculate covariance matrix function. The people is not yet watching that calculate covariance matrix video. They need to watch that, because otherwise they can understand this little difficultly. Okay, group 1 dot pushback sample, and this is done. Yeah. And after this, the same thing we need to do for the group 2, of course. And this is can be, of course, this is gonna be 2. By the way, we are wrong here. This is gonna be y, because the first column is gonna be x and the second is gonna be y. By the way, these are according to all is we are just preparing the input for this calculate covariance matrix. This is important. Okay, then we are gonna push to group 2. After that, maybe we can simply write the output, write these groups into the console, so we can see at least how they are looks like, because I'm expecting they need to be 2 column. Okay, here's something wrong. The first row is wrong. Why is like that? Okay, they are writing the 210 to the second. Okay, maybe, okay, this is 0, of course this is 1. Let's try now. Okay, why all is, yeah, here, because we change here, we need to change here, of course. There is a mistake here, index mistake. Yeah, okay, now they are all fine. So yeah, what I'm doing, just assigning these points into a mat. So because calculate covariance needed that, 285, 367 and 336, yeah, 292, yeah, continue like that. Okay, so I prepared my groups, math groups. This is important. Then we are now the next step. Okay, here maybe step 2 we can write. Step 2 is gonna be now calling the function calculate covariance matrix, and in here we need to give our samples group 1, and then the covariance 1, mean 1, and now the point is the enumeration we need to give according to the previous video. You need to check, of course. In here we are gonna make covariance normal, and now since I included points each row, so I'm gonna define the covariance rows, which is in here, and after that the type of the math, which is 32 float, and this is done. And similarly I need to call for the group 2 also. Okay, and I get my covariance, I get my mean, so now everything is done. Yeah, okay, now step 2 is done. Step 3 is calling the Mahalanobis function, but in here the important part is maybe we need to make a while loop, because I wanna pop up many new points, so I wanna see them also. Let's make a while loop. Okay, it can be forever. After putting here, it will be triggered by the keyboard. Okay, and I need to get my new point, which is gonna be point. Okay, and let's say new point is equal to, and okay, we can make like this. Now I need to call the random function of standard library, random. Okay, after that, since for this is gonna be the x point of the point, so we need to make input is my, or 500 can be, because any number until 500 is gonna be enough. Similarly for the y-axis, and my new point is get. Then this new point is needed to be calculated the distance via on the but of course similarly for this point we already made this sample, also we need to do for the new point. Okay, and this is done. Of course this is gonna be new point, and no need the index numbers, and I get my sample. So now I can call the Mahalanobis distance. Mahalanobis distance function. Input is gonna be sample. This is the critical part. And the second, even here written input array volume 2 is not explained well in the documentation. When I check the Gary-Bradsky example, it's just putting the mean value to here. So I'm gonna put to, sorry, it's just putting covariance first of all, then the mean value putting accordingly. Okay, so this is the distance to the cluster 1. So I'm gonna put, because giving the output as double, the result 1 I'm gonna write, and also similarly for the second cluster I need to calculate. Okay, so now okay, for each cluster I get the distance for this new point in here, result 1 and result 2. So they are gonna give me some numbers, but the point, the smallest one is gonna get the new number. That's the point. So let's compare first of all. If result 1 is smaller than result 2, then in here I'm gonna get the circle as yellow, which is the group 1, yeah, in here. So I'm gonna circle one more. The new point is get by the group 1, which is in here new point. Okay, then if else, of course, otherwise it's gonna be blue, because it belongs to blue otherwise, which is gonna be like this. Okay, let me check one more time. Everything seems fine, but before converting it into the color, new color, I want to see it in, let's say, white color, because I wanna see. Then I will press to the keyboard again, then it will give me the belonging cluster. Okay, maybe a little complicated, but the code is in here. I think I did everything right. Let's run the code. Okay, seems I didn't do everything correct. This is gonna be columns, I think. Let me check. Did I make mistake in here? Let's run the code. Okay, something wrong in here. Okay, group 2. Okay, group 2, group 1. It gives me okay, it gives me this one of the, let me check this one. This is gonna get the, okay, let me check the Bradsky example. Mahalanobis. First of all, giving the means. Oh, we gave the covariance first. Okay, this is the mistake. So we need to change it as mean. The first value is gonna be mean, then the covariance. Sorry, that's why it gives me error. Okay, so the second is gonna be mean, then the covariance needed. Okay, let's run the code again. Now it's working fine. Okay, this is the new point, because this is randomly coming. So now we are gonna learn. I think it belongs to yellow. Yeah, it belongs to yellow. And the new point, of course, it belongs to yellow also. This is maybe blue. yellow again. Okay, all is yellow. Why it's like that? Oh, this is interesting. Okay, this is blue. This is wrongly given. I don't know. This is also interesting. This is also blue. Something wrong in here, I think. Let me press more. Yeah, some classifications are wrong. Yeah, but all new points is calculated via on here, even mostly correct. What we are doing randomly new points coming, but even in this way, some wrong. For example, this is should be yellow. I think there are something wrong. What we are missing, I don't know. Maybe already the function is not working perfectly, but not really bad also. At least the points coming in this side clustered well. Let's run the code from the 0 again. Maybe we need more new points coming, or same points coming. It's also interesting. Okay, anyway, basically I just tried to show you this function is used for clustering. Even for this example, maybe the number of the clusters are not enough. The counter maybe should be more. Some points are showing me wrongly. Yeah, maybe needed to be checked detailedly, but mostly working fine. It's just clustering the new data coming into the clusters. Okay, you can also check Geribraski example. It's just taking the points via on k-means. Since we did not yet learn this one, I'm just wanna create my own data by myself. Yeah, this is a little also long video, sorry for that one. Simply I just wanted to show how it's working. Yeah, because documentation is not clear. That's why I also check Bratsky example. Okay, see you in the next videos.